Okay, in this podcast we're going to look at how do we do multi-step conversions so I can string together multiple factors to solve more complex problems. So let's first talk about three conversion factors. So if I am trying to go from moles, let's say to grams, mass in grams, I need to use the molar mass, right? Either the mass on the periodic table or the combined masses from the periodic table. But I can also go from moles back and forth to volume in liters by using 22.4 liters. The molar volume, right? 22.4 liters are in 1 mole. In addition, I can also go between moles and number of particles. I'll just call this number of particles. And here I use Avogadro's number, 6.022 times 10 to the 23rd. So this is a little mole map. I can convert between moles and mass, moles and liters for a gas. This is specific to a gas. Or moles and number of particles, atoms, molecules. There is, however, no direct relationship between particles and grams and volume, or volumes and particles. So if I wanted to go from, let's say I wanted to go from grams to liters, I have to go through moles. So I have to do this and this. I cannot go direct. Same thing as if I wanted to go from, let's say, mass to particles. I cannot do it directly. I need to go from mass to moles and moles to particles. So I always have to go through particles. Let's take a look how we can apply that. So here we have, we want to know how many grams, that's hard to find, are there in 7.25 times 10 to the 23rd atom. So if I think about it, I'm starting with grams and I want to get to atoms. So in order to do that, I need to go first to moles. And to go from grams to moles, I'm going to use my molar mass, right? And to go from mass to atoms, I'm going to use Avogadro's number. Okay, so let's string it together. I start with my given 7.5 times 10 to the 23rd atoms of magnesium. And what I know is 6.022 times 10 to the 23rd atoms are in 1 mole of magnesium, right? This is still magnesium. But I'm not done yet. This will give me moles, and I want to know grams. So 1 mole of magnesium is going to be, I look it up in the periodic table, and it's 24.31 grams of magnesium. Now, if I've set this up right, then my units, I should be able to get my units to cancel. Here's atoms of magnesium, moles of magnesium, moles of magnesium. And I should be left with the units that I want. And in fact, I am. So now it's a plug and a chug. So it's 7.5 times 24.3 equals, divide by 6.022 times 10 to the 23rd. If I do that, I end up with 30. And I'm just going to put a dot there because that's a significant number, grams of magnesium. Okay, let's take a look at another one. Here I want to know how many molecules there are given the volume. So I'm starting with volume, right? I'm going to have to go to moles, and then for moles I can go to molecules. So volume to moles is going to take that 22.4 thing, and moles to molecules is going to take Avogadro's number. Okay, so if I start with my given, which is 75 liters of propane, what I know is there are 22.4 liters of any gas, including propane, in 1 mole of propane. But that's going to give me moles, right? Liters of propane will cancel, give me moles, but I want molecules. So what I know is 1 mole of propane is going to give me 6.022 times 10 to the 23rd molecules of propane. Alright, now I can cancel out moles of C3H8. So I'm left with 75 times Avogadro's number, 6.022 times 10 to the 23rd equals, divide by 22.4, and when I do that, I get 2.0, I want two sig bigs, right? 2.0 times 10 to the 24th molecules of propane. Okay, let's try another one. Okay, in this case I want to know how many liters are in 2.5 grams of methane, CH4. Okay, so I'm starting with grams. So I've got grams here. I got to go to moles, and then when I get moles, I can go to liters, right? Grams to moles is going to involve my molar mass. Moles to liters is going to involve 22.4. Okay, so I'm starting with 2.5 grams of methane, CH4, and what I know is 1 mole of CH4 is some number of grams of CH4. Okay, carbon. Each carbon weighs 12.01 grams. Hydrogen, I've got 4 of them. Each is 1.01 grams. So if there's 4, it's going to be 4.04 grams. That's going to be 16.05 grams. That's going to go here. Okay, so this would give me, I'd cancel out my grams of methane. This would leave me with moles, but I don't want moles, I want liters. So what I also know is that 1 mole of methane, or any gas, is 22.4 liters of methane. Okay, here I can cancel out moles, and I should be left with the units that I want, and in fact I am. So it's going to be 2.5 times 22.4 equals, divide by 16.05, and when I do that, I end up with 3.5 liters of methane. And that's going to do it.